Hey guys, it's Jeremy Wellborn. I am here at the Peterson Museum for the 2023 Z06 reveal, and I've come across Dustin Gardner, who is the Assistant Chief Engineer for the LT6 small block that's going to go into the Z06. And so I'm going to introduce you to him and then find out everything we need to know about the small block LT6 that will be in the 2023 Z06. All right, this is Dustin Gardner. Assistant Chief Engineer for the small block that's going into the Z06. This is the LT6, and so would you mind taking us around the LT6 and kind of tell us about how you guys developed this engine and everything about it, everything we need to know? That'd be awesome.
And the LT6, this is truly a clean sheet of paper. We started from scratch with this engine to accomplish the goal, Tad has been talking about, which is a naturally aspirated engine.
Yeah.
Truly achieves, better than LT4 power performance, right? We had to start over. So at the heart of the engine is, as we've been talking about it at length, is a flat plane crankshaft. So in doing that, we get a lot of rotating weight out of the crank train versus a cross plane crank, right? So we start out with a light crankshaft, couple that with lightweight forged titanium connecting rods, low profile forged aluminum pistons, also the theme here, right? We're getting the mass out of the parts that are moving. So that at its heart, the other benefit the flat plane crank is giving us is balanced breathing. So bank to bank breathing. It's, one cylinder on one side, then one cylinder on the other side.
Right.
Through that, then we can get into the tuning of the intake, which I'll work up to. So moving up into the combustion chamber, another unique feature is our fuel injection system is on the exhaust side versus the intake side is more done traditionally. This is done for several reasons, one being intake valve packaging, the second being also you get some free mixture motion when you impinge the fuel in the air from different vectors, right? Which allows us to unrestrict the intake side a little bit and not have as much tumble to get a good air-fuel mixture.
Great.
With that, so then we have sodium-filled steel exhaust valves, titanium intake valves, once again lightweight, theme, walking up the valve train, dual springs, to enable the high-speed valve train dynamics that we require. And this is a true mechanical finger follower valve train system. So there is no hydraulic component. So this is the finger follower, as we call it. This is a MIMD precision part that is DLC coated for wear prevention. It has its own lubrication oil jet to keep these surfaces lubricated. And then hardened, polished cam lobes act directly on this.
Okay.
So given there's no hydraulic component, we shim every valve location in build. So when we build the head subs in Bowling Green, we assemble everything fully torqued down without shims, measure the clearance, take the cams out. It goes into a robotic cell that then selects all 32 shims required for that cylinder head set, assembles those shims, comes back out, we reassemble the cams, check it. Then after the head sub gets torqued to the engine block on the main line, we measure it again as a triple check to make sure nothing's changed. When everything is torqued down, everything is still in spec.
Okay.
And that lashed valve interface is lashed for life. There's no service interval or any requirements around it. So
that's great.
We'll never have to touch it again after it's built.
Wow.
So building up from there, obviously the name of the game with a flat plane crank high revving engine is tuning the airflow. That's where the benefit is at high speed. So as you can see, inside our dual plenums, we have individual trumpets for each cylinder.
Yeah.
And these trumpets actually vary as you move forward on the engine, based on how the air is going to pulsate and move through the engine.
Yep.
And you can see a little bit better on the cutaway back here. But the length and the geometry of the tune port is really what factors into its ability to breathe at high speed. And from peak torque up to peak power, the volumetric efficiency of the induction system is greater than 1. So if you think about it, you're getting more air in than at the pressure. It's almost, I hate to say it's boost, but you are getting more air in the cylinder, or pressure in the cylinder than atmospheric.
Incredible.
Because of the velocities and tuning in the intake manifold. And that's further enabled by the 3 tuning valves in the middle. So these actuate, the rear 2 actuate together. Or I would say rear, because I look at this. It's really the front of the car. These actuate together. This one actuates independent. So those 2 sets of them will move independent of each other throughout the RPM band to maximize torque output.
Okay. Wow.
Twin 87 millimeter throttle bodies. Low restrictions, the name of the game, when actually aspirated.
Right.
Feed the beast. So valve train airflow. Obviously, stainless steel tubular headers. They're a 4 into 2 into 1 configuration, which is the best balance for performance as well as emissions.
Yeah.
The other thing that's really unique is the lubrication system on this engine. Down the right-hand side of the engine is the oil pump assembly. Half of it's cut away here. So the pressure pump is up front, directly under the oil tank. So fresh oil from the tank directly feeds the pressure pump into the lube circuit. Where it really gets interesting is oil coming back out of the engine. So there are 6 scavenge stages in this. If you remember the previous gen Corvette, we ran, a single scavenge stage. LT2 stepped up with 2 in the crank, 1 in the valley, so that's 3. The LT6 is easy to remember, has 6 stages.
Okay.
And right here we cut away to an example of one you can see for this, the third crank bay. So we have cast in basically windage eyelets. So this works like a windage tray rather than a normal oil pan. So oil gets slinged, but you can see the direct path up over and into its scavenge stage on the oil pump. So of those 6 stages, 4 are dedicated for each of the 4 crank bays. And each of the 4 crank bays are completely sealed from each other. Wow. So that gives us several benefits. One is in managing windage gases. So now if you think about it, in each crank bay, you only have 2 pistons, and they're constantly doing this. So you're just moving a column in air like this. Or a cross-plane crank, where you can have pistons out of phase, you have to move air forward and aft, and that's all losses. The other benefit of the sealed bays with the dedicated scavenge cores is we can pull almost 80 kPa of vacuum in each of the crank bays. So think about that vacuum of getting oil and air out, and blow-by gases out. So your crank, counterweights, and rods are basically slinging around in a near vacuum.
Wow.
Once again, great lubrication performance because the oil's in the tank where you need it, and you're taking a lot of parasitic losses out of the lower end because you're not fighting through oil mist and air and stuff with the counterweights and the rods. Fuel system is also a little unique. We moved the fuel pumps are mounted in the valley. They run on a kind of a short camshaft that you can see on the front is driven off an intermediate sprocket. So crank sprocket to the intermediate sprocket, then you can see here it's a 2-lobe camshaft that runs the fuel pumps, and they stroke twice per cam revolution. And this runs at cam speed. Then each pump is essentially its own 4-cylinder system. So the front pump feeds the right-hand side, and this pump got cut away. This pump feeds this fuel rail on this side. And
it's a work of art.
Yeah, similar to the LT2, the oil tank is on board to the engine, which is great because then your oil supply is, as I said, right on the pressure pump. Centrifuge oil air separator at the top, so oil comes out of the scavenge, it's coming with a lot of air because basically you're running 6 vacuum cleaners out of there. So that comes up here, separates the oil and the air, and then we actually balance the airflow. It's not on this engine, there's a big breather tube. So we balance the pressure to the front cover where we don't necessarily need a vacuum. So that's where the airflow is balanced out. And then active PCV then regulates that airflow to dump any extra gas into the intake to burn like a typical sealed PCV system would.
Wow.
What else is interesting? It's a aluminum viscous filled crank damper. So the damper is much lighter than the traditional iron dampers that we would see on like the LT2. And another neat factoid, so all in on this engine compared to an LT2 only weighs 1 kilogram more. So you're getting, close to 170 horsepower more with only 1 kilogram weight penalty. And that's coming from everything I talked about on the bottom end of being lighter. Because we do have 3 more cams, 4 times the springs. I mean, there's more there, but the benefit in the lower end of the mass savings there keeps the weight down. So that was a significant.
That's huge
as well.
It is. Run through the numbers, the performance numbers with us real quick.
So the performance numbers, it'll make its rated speed is 670 horsepower at 8,400 RPM. Fuel cutoff is at 86. From 84 to 86, it doesn't nose over. It gets on the torque curve is a little flat there, but it'll maintain that 670 pretty much till you hit the fuel cutoff.
Wow.
And then peak torque at 460 foot-pounds is at 6,300.
Okay.
So think about that in the realm of the LT2, right?
Yeah.
You're about done when this guy's just waking up.
Yeah,
right?
it gets happy. Yeah.
And past
That's
63, it screams to 86.
Wow.
Because the lightweight and the power,
Sure.
it wants to accelerate with ferocity. No
What's the compression ratio?
12.5 to 1.
12.5 to 1. Wow. Dustin, thank you for giving us a walk around of the new LT6. Phenomenal engine for the new 2023 Z06 Corvette.
So inside.